So graphs are very useful to us in getting a picture of a relationship, okay? So in this equation that we have right here, this is going to graph to be a line. I'll just spoiler alert. This is going to graph to be a line. And what we're trying to do is show a relationship between x values and y values. Now, a lot of times graphs are used out in business and medicine and all kinds of fields to represent data. They'll show you in a graph, right? You've probably seen graphs like that before. And so how do we, create that graph? How do we get a picture of what's going on? And that's what we're doing. The picture, we're just trying to get a picture of this relationship between variables. And I'm having technical difficulties. Okay. So to do that, oftentimes we'll make what's called a table of values. Now, I make my table of values usually vertically. I've seen them horizontally in books, but I usually make it like that, like a little T, and then I have x values on one side and y values on the other side. Now, if I have an equation where y is by itself, then I'm going to want to pick x values because it'll be easier to do the calculation. Now, what x values can I have? Well, if I look at this equation, what types of numbers could x be? And it could be any real number, to be honest. They're all on my number line, on my axes. This is a real number coordinate system, okay? We have other coordinate systems, but this is a rectangular coordinate system, and it's based on an x-axis that represents real numbers and a y-axis that represents real numbers. Okay, so pick your favorite number. Now, I would pick a small number, something between -10 and 10, because that's how big my grid is. So maybe I want to pick -2 for x. Well, then to find the corresponding y value, I plug -2 into that equation for x. Now, it's important that you get it in the right spot because you didn't choose a y value. You could do that, but I didn't. I chose an x value. And so then I do this calculation and I get y equals 4 minus a -2 is 4 plus 2, which is 6. So there's an ordered pair out there, -2, 6, that makes this equation true. Okay? Well, that's one point. I can graph that point. Let me graph it. So -2, 6. Right there. I'm not going to label it with a letter. That is just this ordered pair that I have just graphed. Okay, I plotted the point. All right, that's great, but I need more points. So I'm going to pick another value. Maybe I want to pick 0 for x. 0 is often a good one to pick because it shows you what's happening at 0. So I get 4 minus 0, which is just 4. So I picked another value for x. I get another ordered pair, which is 0, 4. And if I graph that, 0 meaning don't go right or left, 4 up. 1, 2, 3, 4. And I get that point right there. I could draw a line at that point, but usually we like at least 3 points. So maybe I want to pick a positive value. Maybe I'll pick 3. Let's see what happens if we pick 3. So I go back to the equation. Sometimes I separate these with squiggly lines. So I go back to this equation. This is what I'm trying to get a picture of. Y equals 4 minus 3, or y equals 1. 4 minus 3 is 1. That gives me another ordered pair, 3, 1. Now I could make more points. I could pick more values for x and get a whole lot of ordered pairs, but I'm going to say this is enough. All right, so I graph the point 3, 1, 2, 3, up 1. Those points, because I told you we're graphing this and it's going to be a line, that means those points should line up. If they don't, something went wrong. And you could pick more x values, or you could go back and look at your work and see where the mistake is. But I told you it was a line. Now, they're not always going to tell you. We're just starting our graphing, but later on we'll see more of that. Now, we're going to connect the lines, or the points, with a line. So it makes a straight line like that. A ruler helps drawing those. Now you might be saying, well, I don't want to pick these x values. I was going to pick -1, and I was going to pick 10, and things like that. You know what? That's great. You get to pick whatever values you want when you're making a table of values. I recommend picking points that actually fit on your graph because that'll make it easier for you. But if you picked other points, you would get the same line if you do it right. So they're just representative of points on the line, okay? You pick 3 or you pick 5 or you pick 10 points. You're not picking the points. You're picking x values and calculating the y values, but they're all going to line up. This line, I drew an arrow here, that line represents all the ordered pairs that satisfy this equation. This equation, I could have any value, any real number for x is represented by that line. I mean, let's say you wanted to have x be 15. Okay, so I put an x there. Say you wanted it to be 15. What would y be? Well, y would be 4 minus 15. That's a positive 4. 4 minus 15, or negative 11, right? That ordered pair, 15, negative 11, it's not going to fit, but if I use my imagination a little bit, and I go 15, over here 15, and then down 11, is it going to, is my line going to, if I extend my line, is it going to hit there? Well, pretty close. The further out you go and the more off grid, then you get some inaccuracy, but it would be on that line. Okay? All right, so the picture here represents the equation here. Okay? That's important to understand. One more thing. So the picture, the line that I have drawn here, the orange line, there are an infinite number of points on that line. Like you could have x be 1/2 or 3.3 or whatever. They're all being represented on that line. That's why we have to draw the line to represent all the ordered pairs.